So guys, this is our capacitive touch button and this is the LED. See, I will press it, simply touch it, no need to press it, LED turns on, I remove finger, turns off. I press it, it turns on, I remove it, it turns off. See, I press it, it turns on, as soon as I release the finger, turns off. See, it's simple as that. Hello guys, welcome to learning microcontrollers. In this video, I'm going to show you how you can interface a TTP223 capacitive touch button with a PIC16F877A microcontroller. So let's get started. So guys, this is our PIC16F877A microcontroller having 40 pins. It's a DIP version. And this is the TTP223 capacitive touch module. You can see that it's a touch sensor as mentioned on this body as well. You can see there are total of 3 pins here. The right one is a ground as labeled on the body as well on the PCB. The center one is the VCC and the left one is a signal pin. And this signal is not an ADC pin, it's just a digital pin, either 1 or either 0. When the button is pressed, a 1 will be sent. If not pressed, it's a 0 by default. So guys, let me show you how to connect it with the PIC. Connect the ground directly with the ground of the PIC, VCC with the VCC of the PIC, and signal. For the signal, you can use any available digital input output pin or a GPIO pin of your PIC. I'm going to use the pin number C2 for the button. So guys, whenever this button will be pressed, you will place a finger on this path, or on the back side there is an aluminum plate. You will place a finger here. Then a 1 will be sent to the PIC, and then we will program the PIC in such a way that it will turn on this LED. So now let's connect this LED with the PIC. As you know guys, LED has 2 pins, one is longer and one is shorter. Longer one is always the power and shorter one is always the ground, like this. So this is a ground, this is the power, and you cannot shuffle these 2 pins. LED is not a non-polar component, it's a polar component. So you will not shuffle these 2 pins. Shorter is always the ground and longer is always the power. Now guys, connect the ground pin directly with the ground of the PIC like this. And for the power pin, you will need a 220 ohm resistor, or this is just a safety resistor. You can use any value from 100 to 500 ohm. The higher the resistance value, the dimmer the LED will get. So you can adjust LED brightness using this resistor as well. Now guys, you will connect the power pin, that is the longer pin of the LED, with the one end of the 220 ohm resistor like this. From the other end of the 220 ohm resistor, you can use any available digital input output pin of your PIC microcontroller. I am going to use the pin number D2 for this, like this. In this way, our connections are completed. Now we will program this in such a way that whenever the code will run, what is going to happen is that we will press the button and this LED will turn on. For as long as we keep the button pressed, the LED will remain on. So let's get to the hardware before we move on to the programming. So guys, this is the hardware I have here. As you can see, this is the capacitive touch module here, face down, and this is the LED which one will be blinking. See, only one LED will blink. So whenever I will touch this, LED will turn on, LED will remain on for as long as I had pressed this. Once I place my finger off, LED will turn off. So this is simple as that. So let's get to the micro C for PIC programming. So guys, this is our micro C for PIC. Let me zoom in. This is the version 7.2.0. You can use the latest versions if available. Upgrade to that. I suggest always use the latest version. Click on new project. New project wizard pops up. Click on next. Write the name of the project. Capacitive touch module tutorial learning microcontroller. This is the name of the project I wrote. You can write any name. Select the path where you want the hex file to be generated. Select the microcontroller you are going to use. I am going to use a PIC16F877A, and select the crystal you are using. I am using 20 MHz crystal. Click on next and finish. So guys, we are done with the initial setup. Now before you move on to programming, first of all press Ctrl S to save your work. Now guys, we have only 2 things here. One is the capacitive touch input and other is the LED. So we only 2 pins are going to be utilized. For the capacitive touch input, trace C.F2 equals to 1. We are using pin number C2 as shown in the presentation. So just like in Arduino, you use the pin mode input command. Here you use a trace register. 1 means it's an input, 0 means it's an output. So pin number C2 has been declared input for button. cap button input pin. So now give the initial state. Port C dot F2 equals to 0. As I had tested already, TTP223, this module, whenever the button is pressed, it sends a 1. So by default it must be 0. So whenever the button will be pressed, a 1 will be sent. So by default we give the initial state to that pin where this button is connected as 0. Now give some initialization delay. This is not necessary, but I suggest you always give a initialization delay in the one time loop. 20 will do fine. Now guys, we have our button initialized. Now we initialize the LED, which is at pin number D dot F2. So I write trace D dot F2 equals to 0. Now see the difference here. Just like in Arduino, you write pin mode output. So in case of micro C, you use a trace dot pin name, and then 0 means output, 1 means input. Now the LED will be always be connected to the output pin. So we have declared the pin as output, while the button is for the input. So we had given 1. For the output, we are giving 0. This is for the LED. Now the initial state of the LED, by default the LED must be off. Just copy paste this and change the pin to D dot F2. That's all. And initially LED must be off, so it is 0. 1 means on, 0 means off. Now give some initialization delay. 20 will do fine. Just like in case of Arduino, you use the command digital write high low. In case of PIC, we use this command, and 0 means it's low and 1 means it's high. We have our LED, we have our button pin initialized. Now we can move on to the forever loop. So write down while 1 starting here, ending here, and inside it write your code. What we are going to write is that if the button is pressed, that is port C dot F2 double equal to 1, then we will wait. We will not wait if the button is pressed. Okay. And in case the button is accidentally pressed, something has pressed the button, like some organic material, some insect have passed by or something like this. So we give some delay as well. This is just like a safety delay here. We give a delay of like 50 milliseconds. If the button is pressed, okay, and it is being pressed for more than 50 milliseconds, then again check. If the button is still pressed, then what it should do, and both the brackets here. Now what it should do, the LED will turn on. So this is the LED, just turn it on, make it 1. Now the LED is 1. Now in the other case, else if the button is not pressed, then LED will remain off in the initial state. So this is the initial state, just bring it in the else loop like this. So LED will turn on if the button is pressed for more than 50 milliseconds, and it will remain off if the button is not pressed. So that's all. So if we keep the button pressed, LED will remain on. If we remove the finger from the button, LED will turn off. That is what we expect from this program. So let's build it and run it into the microcontroller and see what happens. So guys, I click on File, Import hex file in the PIC16 programmer, and this is the hex file. I click on Write. The new program is being written. So let's get to the hardware. So guys, this is the hardware. The program is being burned. So let me power it up using the PIC16 tool. I click on. See that LED has not turned on as we gave the power. That's a good sign. By default, the LED must be off. Now I press the button. See, LED turns on. As soon as I remove it, it turns off. See, I press it, turns on. I remove the finger, it turns off. See, it's simple as that. Now see that this is a capacitive button. There is no tick tick like a normal push button. You feel tick 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 tick. There is no mechanical parts in it. It's like a solid state. So it has very high end advantages over a normal tick tick button. See, it's very quick, very fast, and I press it, it remains on. I release it, it turns off. I will give you this code in the description of this video. Still, if you have any questions, you can ask in the comment. So guys, I hope you learned something from this video. Thank you very much for your time and have a nice day.